Hello, ROS developers. Welcome to this presentation of the project of Dimitrios Mavridis. So in this presentation, Dimitrios, who has been studying the ROS Basics Python course, is going to present the final course project. So as he went through the course, he had to create a project which integrates all the knowledge that the course provides into a single project with a single robot. Then in this case, Dimitrios is going to present to all of you how he has achieved to finish this project and how it works with the robot. Then without further ado, let's go with Dimitrios. The audience is yours, Dimitrios.
Thank you, Ricardo, and thank you for giving me the opportunity to develop this project and also the people watching. So I'm very happy to present the project that I developed using ROS for Python. And without any delays, let me switch straight forward to the environment itself so that we will be able to see what this project is about. Can you confirm that you're seeing my screen, first of all?
Yes, correct.
Thank you. So this project, what we are seeing here is a robot located here. I have done an initial positioning of the robot, and this robot is in an environment that consists of 4 walls, as you can see here. The purpose of this project is to use the robot, the ROS operating system, that will have some certain specifications for the robot to move. First of all, here at the bottom there is a wall, and the robot will have to position itself so that it will start moving in parallel to the wall. It will use one service node and one action node, and without speaking more, let's see what we expect from this robot to perform, and then we're going to explain a little bit more the operations that take place in the code. So as you can see here, I'm launching this launch file, and as long as it is launching, as you can see, the robot starts moving. First of all, it is turning around, and it will position itself towards the closest wall. Then it moves. You saw that it moved a little bit forward to have a distance of 0.3 meters to the closest wall, and then it turns itself around to be in parallel to the wall. As long as this initial positioning is achieved, it will start moving in parallel to the wall, trying to keep a distance between 0.2 and 0.3 meters. That is the specification. When it sees a wall, it means that the reading of the sensor is smaller than 0.5 meter. It will start rotating to avoid that wall, so it will move away from this wall. And because it is a rectangle here, we expect it to follow a rectangle path. And as you can see here, it turned to the opposite side. Now it will detect again a wall. And here there is an obstacle. Because this robot, it has some basic intelligence, it will consider this as a wall and will avoid it at the same time. And then it will try to come back to the wall itself. But according to the specification, it has completed one full lap of this environment, and it received the command to stop. So this looks all nice in the simulation, and let's quickly spend a bit of more time to see what it is underneath this code that we saw. Also, as an extra, this robot is the orbit of this robot is saved and it is plotted in this graph, and we see that points of every 1 second are taken, and we saw that the robot, how it moved around this place, around this environment. So let's have a closer look that we saw the demonstration, what we expect from this robot to do. In the meantime, it will be good to show to show this in the real robot. So allow me to connect there. And as you see here, the environment, it is what we saw earlier. And the robot, in this robot operating system, we have defined three main nodes. One node is the find wall node, and this is executed at the very first time, where the robot, it is found itself in an arbitrary position, and it has to position itself in parallel to the wall. And this is what we saw at the beginning, where it performs an initial rotation, then it moves towards the wall, and then it turns to the right, so that it positions itself in parallel to the wall. Then the main navigation node is executed. And what happens here in this node is that there are two sensors. There is, more precisely, there is one laser sensor that it reads the environment, and we're receiving an array of measurements that are 360 values. What we care is the values at indexes 180, which is the front, 90, which is the left, and 270, which is the right. So the robot senses the environment, and if there is any obstacle at these three positions. So if there is no obstacle, the robot starts moving with a predefined linear speed. When, for example, in the case that it moves forward and detects that there is an obstacle, in our case, a wall, this gives the robot, as you see here, it will read the scan, and this gives and then when there is the obstacle, there will be a command to the robot just to switch to turn to the left. And this is performed. This will be performed forever. However, as you can see here, there is an action node, and this action node, it records how much distance it has covered so far, and also it records the initial positioning of the robot. So as X and Y coordinations. So when the robot starts move around, and let's switch to the environment. When the robot starts moving around, better to see it here in this case. Let's say this is the initial position. When there is one lap and comes back here, it will notice that it has come close to the initial position, and this will imply that one lap has completed, and it will stop. So this is in general what the behavior of the robot does. Now it will be very, very interesting, because our time for that is a bit limited. It will be very, very nice to see that in the real life, in a
We
real
are still
robot.
on time, Dimitrios. We are on time.
Great. Thank you. So let's do that in the real robot. So what will happen now is that what we did earlier in the simulation, exactly the same code is loaded in the real robot that we have remote control. And if we are lucky, we should see that it will have the same behavior in reality. Let me make a correction here, so it will be ready to run. I'm loading again the command environment.
Can you first check, Dimitrios, if you can see the topics of the robot in that terminal?
Absolutely. So when we type ROS topic list, we should see all the topics that are available. So it is taking some time to respond, but it will get there.
Yeah, sometimes it takes the first time. But
that's right.
It should already have shown the answer.
Still, it is.
No, that's not normal. This is not normal. Okay.
Okay.
Can you try to disconnect and connect again to the robot?
Certainly.
Yeah.
So this is what happens in in a
Yeah,
live demonstration,
yes,
especially when we work remotely.
exactly. So now it has already.
Let's try once more.
Um, I'm not sure that is correct. I didn't see you press again to connect. Have you pressed to connect?
Yes, now, okay, now it is turned off.
Wait until the process is done because
I
the
understand.
yeah, because the terminal, you see the terminal on the bottom
That's
left,
right.
on the bottom left, and before
Yes.
pressing that now,
Okay.
okay, now you can press turn on. Exactly.
Yes. And in the meantime, you will have the chance to see also the code itself. So all the files that are here. What we will eventually execute is this main program. So I think it is ready now to launch again the shell.
Okay, try first checking the topics.
Yes. Not echo, ROS topic list. It says that we are unable to communicate to the master.
Yeah, I think it's because the behavior is not. Wait a second. Now,
It is
yeah,
loading again.
now this is the one. Yeah, this is the correct one.
It has also a weird number here.
Yeah,
Let me close that. Shall I close that?
sure.
Yes. Let's give it the time it needs.
Yeah,
But in the meantime, I will
go
have the
ahead.
chance.
Yeah.
Yes, I will have the chance to explain that we have those files here. The most basic ones are this command velocity publisher, and this is we have the velocity of the robot, which defines the movement of the robot, either straight, linear, or turning. And we just got. So this is for the velocity, and we have the laser that we explained earlier that we are always reading the laser value, which is this this sensor at the top of the robot. Let's see if we are like it. That's fantastic. I think we see this command velocity. So this is the node to control the robot, and also we see the scan, and these are the readings from the laser. Let's see the time. Yes, let's show ROS topic.
You still have 10 minutes of
Yes.
usage.
So let's show the audience, for example, what the scan is doing. So the scan, we're reading almost like forever values, and we are using those values to control the robot. So let's start. Let's execute the node that we saw earlier, which takes those values essentially and it does the processing and the according behavior. So let's hope that it will work now. We see that it is defining the servers. Okay, that's interesting. So the robot now should start turning around. That's great.
It has a 2.5 delay between your program and the image that you receive there. So there is a 2.5 delay, seconds delay.
Yes. Okay, so now it is turning around, trying to find the closest distance to the wall. So as you can see here, this distance should happen when this goes to 180. So let's hope that this will be the case. This is the first rotation. So in theory, this is here at the bottom should be the closest distance to the wall. So it is approaching. I have to mention that it is not, even if it is like plus minus 5, I see there may be a problem. So allow me to do something else to position the robot a little bit in a more convenient position. So I'm manually switching the robot.
That is allowed.
Yes.
That's happen. It's like when you are if you had this robot beside you, then you could do it manually. You know,
Exactly.
moving the robot, but you are far away from it, so you had to use this program in order to
Yes.
position at the proper location for your program.
And as we said earlier, the robot doesn't has a basic intelligence, so it will be required to do some initial positioning. I'm trying now to turn it around a little bit. I see it is not responding though. That is not great.
What's the problem?
The problem is that it doesn't seem to respond to the remote command.
Okay. It looks from it looks like everything is correct. Can you close? Can you do a ROS topic list again and see if you can see
Yes.
the topics? No, it's like it looks like it has lost the connection.
Unfortunately, yes, because when I was trying to connect remotely, it wasn't connecting. However, we have that. I have done this task earlier while preparing, and I have a YouTube video that I can share. It will be exactly the same thing.
Go ahead.
You know, second best option. So I have here the robot, and let's start seeing what happens. So I'm doing exactly the same thing as I was trying to do here. So initially the robot is positioning itself here. It turns around, it moves towards the wall, and when it gets closer to 0.3 meters, it will turn around and position itself in parallel to the wall. And when this is achieved, it will start. This will happen at 270. No, so now very fast it starts moving around, and you see here the odometry. So this is the total distance that is covered at the moment. You see the robot being on the opposite side. Now it will detect a wall and it will start rotating. And now it is cruising in the field because it is a straight line, so there is no obstacle. It tries to keep distance from the wall. Now it sensed the wall at the front and it is turning sharply to the left. Then again, it is moving in parallel to the wall. Then once more, another wall ahead, another turn from the robot. And when it will reach closer to the initial position, it is always checking its distance from the initial position. So now that this has happened, it will stop. And this is the purpose of this behavior. And as you can see here, it has covered 5.8 meters. So this is the behavior that ideally would like to show in real here, but you know this is something that we took earlier, and it works. Maybe I can give it a try. No, it is not connecting.
Yeah,
But
it looks like there is a problem in there. Yeah.
yes, those things happen during live presentations. But I think we get the idea of the behavior. I don't know if I have much time, but I would like to get a little bit more to the code, perhaps.
Yes, you have a couple of minutes more.
Yes. So as we explained earlier, we have three nodes that work together to achieve that behavior. And in this file that will be shared, you will be able to get some further details on the behavior. So here is the environment, the simulation, and the real environment, and finally an orbit of the of the robot moving around the environment. In overall, this work is using the code structure as using the object-oriented programming. And as we mentioned earlier, we have three major basic topics. The command velocity for moving. We are publishing this topic. We are subscribing to the scan topic, reading from the laser. And also there is the odometry that gets the coordinations of the robot. And then the service to find the wall, which is the initial, and the action, which is to measure the distance covered so far and to stop when we are getting closer to the initial position, are combined together in this main program, which this program is the master one that does the navigation and is using the service and the action to achieve the required behavior. Ricardo, that it is from me so far. I hope it was interesting and insightful for the audience to be able to see that behavior in practice, and I hope I managed to transmit some of the enthusiasm that I had while developing it. I have to say that while doing so, I learned things. I made certainly some mistakes, and even the video that I presented, the YouTube one, that wasn't the first one. That was the fourth attempt to get a correct behavior. So through that, I learned, and being able to present something like that like a month ago, I wouldn't think that it would be possible for me to do so. So thank you for this opportunity, and it was a pleasure working on that project, and looking forward to continue to more complex tasks.
Thank you very much, Dimitrios. Awesome presentation and awesome work. So your program is so well done. Can you stop sharing your screen now so we can see you?
Oh, yes.
Okay, let me check that everything is correct here in the transmission so people can see you. Okay, yeah, so the awesome, and the work, it works so smooth. The movement along the wall, that was very, very cool. And also the one about rotating. I must apologize for the problems with the real robot setup. It's all in our site. So nothing is on the side of Dimitrios. It's nothing related to his program. It's in our remote lab. And then as you can see right now on the camera, there was our engineer, Rodrigo, who is watching and trying to solve the problem.
Yes, and this has worked many times because I have tested that several times last couple of weeks. But it happened now that it wasn't available.
Yes, I cannot say anything because it was failing, but it's working all day long with many students, and then just stop right now. So it's so stupid. What can we say? But anyway, your presentation was awesome, and as very professional, you had prepared already the backup, which is the video recording of another day, and that's so everyone got the idea. And now it's time for the questions from the audience. So let me see your questions here and write it down on the chat on the YouTube channel, and I will read loud to Dimitrios so the recording can get also. Well, I can see already here the comments. So then there is Alberto that says very nice, amazing. Rodrigo that says movement looks smooth. And here Christos Tomos, that's cool work and an excellent presentation.
Thank you. He's a good friend. I haven't paid him though.
Okay, then here is a question that says, could it be possible to add a deep learning node to your main program in order to detect the different traffic signals?
Yes, at the moment, this is a course that I will take after, now that I completed that one. So certainly, this behavior is quite basic, just doing a laser reading and perform some task from that feedback. And the next step is to use, for example, the camera and do some with deep neural networks, some signal detection, and then the robot can move to a direction or stop, for example, if this is that signal. So certainly this is the basic project, and then everything can be built from that. So this is more foundational.
Great, great. Then here we have another comment from Thor Panbil. Good job, Dimitrios.
Thank you.
Also, another message from Carlos Mota. Congratulations.
Thank you.
And then Thor is asking also that, well, he apologized. He was 5 minutes late, but he will be interested to know how you manage the scan data. Did you filter in some way?
That's right. So initially, it took me a bit of time to find which. From the laser, we are reading 360, an array of 360 elements, and those are, for example, those are peripheral. So they comprise a circle. So its index is 1 degree. The front is 180 degrees. Left and right are 90 and 270. However, in order to position itself, I was allowing the code a margin of like 5 degrees. So when, for example, the robot is moving forward, in order to detect the obstacle, it reads from 170 to 190 degrees, for example, and it is taking the minimum value, because there can be some errors in the sensors, and this is a safety margin to allow some behavior that, okay, if one measurement fails, at least we have a very close measurement to the reality, to the environment.
Okay, correct. Exactly. In the exercise, the proposed solution of the project that says is that you can filter as you want, and they say you can use, for example, one ray to measure, but one ray is too risky, as you exactly mentioned. So that's a very good idea that you take a bunch of them. Okay.
Yes, and also when the robot for the initial position is moving, is turning around, it has to position itself within 90 degrees. In reality, it's between 85 and 95 for that same reason.
Okay. Okay. Okay, then there is a question from Christos that says, could you please name the greater challenge while working on this project?
Well, the whole project by itself was a challenge. However, I followed the instructions, and the main one, the first task was to do the navigation. So I had to place the robot in an ideal initial position. That was, I would say, of normal difficulty. However, later, adding the service to position the robot so that the robot is positioned automatically to the right place, that was an easy task that took me some time. And then adding on top of that the action server, that was also the final step, and that presented some challenge because I hadn't used an action server or another service server so far. So that took some learning curve some time to get that.
Okay. And what about the integration of all that in a single program?
Yes, certainly. Once its individual step was working, I integrated the first time. It didn't work that great, but with some fine tuning, it was better the next time.
Uh-huh.
So I would say it was throughout the development, there was some challenge, but each step at a time, it looked easier.
Okay, okay. And for this program, did you use object-oriented programming, or did you write in a linear program?
Well, my initial approach was to start in a linear mode. So there I managed to have the navigation working, but then adding the service, the find wall service and the odometry action, and that presented a lot of difficulty to write in a linear fashion. So after 1 week, I started over to use object-oriented programming, and that proved actually to be very useful because it is very easy to expand it and make it more modular. And then the task was, the challenge was to make those individual elements to communicate together.
Okay.
And adding more of that, having its node, like it's the subscribers and the publishers as in the object oriented, it gave me a lot of options at the end, because when it allowed to write commands that are more high level, for example, move forwards by that speed, or turn to the left or turn to the right, and making everything in that sense more modular. And also I used, because there are many parameters, I used at the end one single file to include all those parameters in one place. That proved to be very useful to avoid mistakes in the process, because there's a number somewhere that you forget, and you see an undesirable behavior. But if you have everything in one place in terms of parameters, that helps to detect perhaps a wrong value.
Okay. Let me tell you here. There are some comments more. Okay, Tor. Okay, she's saying thank you for your answer, and also Christos, and keep up the good work. And I think that's all for the questions, and that's all. So thank you very much for your presentation, Dimitrios, and congratulations, because you have made the full course from the beginning to the end, which is the most difficult part, which is the presentation. I mean, prepare the whole project, make it work as it worked in your case, and then finally do the presentation. So that's the whole project thing is the most complicated part. So congratulations for that.
Thank you for giving me this opportunity. I had a lot of fun, and it took time to learn those things, but I feel much stronger now. And hopefully you will see me again in another presentation in a more complex project.
Okay,
thank you very much.
Perfect. Can I maybe I can recommend you the navigation one?
Actually, I have already
started.
saw that.
Okay,
yes.
Great. Perfect. Then I'll see you again, and then I can promise that time everything is going to work on the real robot connection, because that's in our side.
Thank you. I'm sure things will always get better.
Okay. Thank you very much. And for all the audience, that's all for today. Thank you for joining us in this project presentation. Remember, if you want to become a ROS developer, you have to do these kind of things. You have to create your own projects. You have to deliver these projects and share your knowledge with the audience. So you are kind of teaching to others about what you have learned. And this is the moment where you are getting the most gain, in your knowledge about ROS, when you are teaching to others what you have already learned. So if you want to be on this path, then that's easy. Join us at the construct, create an account, and start learning as Dimitrios and other students around the world. So thank you very much. See you on the next student presentation that I don't know when it's going to be. Bye-bye, Dimitrios.
Bye-bye. Thank you.